Welcome to What's New in UVM 1.2 series. Today we're going to cover phasing and the several features that are new to UVM 1.2. So this example actually tries to show many of them, so we're going to go ahead and just take them one by one. So just high level, this example is very similar to previous examples. We've got a component that's inside of an agent that's inside of a UVM test. And most of the interesting code is going to happen in the phases of the component over here. So first we want to cover the new feature that it's now possible to programmatically traverse the phase graph. So to show an example, the methods have been introduced called get adjacent predecessor nodes and get adjacent successor nodes. So we basically take a phase and we get the preceding nodes for that phase. So in this case, we are in the start of simulation phase, and we get the preceding nodes, and we're going to print them out. And you might notice that I'm using the newer messaging system here. We have a message with an element inside of it. So you'll see how it prints out shortly. So we get the predecessor nodes, and we get the successor nodes. So one thing to notice is that when we get the predecessor nodes, they come in this array, right? And we can traverse this array, and on these phases, because each one of these is a UVM phase, we can also call get adjacent predecessor nodes, so to keep going backwards. And similarly with the successors, we can call successor again to keep getting the next phases. So let's go ahead and see how this looks like. So we're basically in the startup simulation phase, and we just get the predecessor nodes and we print them out, and get the successor nodes and we print them out. You'll see from the log file there'll be a lot more messages just because we've got the UVM phase trace on. So let's go to where these messages are. Okay, so they're over here. We're getting the predecessor nodes. And in this case, this is the standard schedule, and in the standard schedule, the predecessor node to start of simulation is going to be end of elaboration. So we print it out here. And then we get the successor nodes, and there's actually going to be two here because in the standard schedule, the next phases are either run or pre-reset. So that basically covers traversing the phase graph. Next thing we're going to talk about is the phase transition callbacks. So UVM 1.2 introduces this new class called Uvm Face Callback, Uvm Face CB. So previously, pretty much the only callback you can do that was phase related was the phase ended callback that was present in your components. But now you can use the Uvm Face Callback, and this will basically call back to this method on every single phase state change. So when we're talking about phase state changes, we're talking about basically things like this: UVM phase state, going through all these different phases, started, executing, ready to end, ended, etc. So now whenever a phase transitions through any of these, you can have a callback. So in this example, we have a class, and all it's going to do is basically print out the actual state name and then print out the phase. So what in this example, we created the callback inside the start of simulation phase, so it's basically going to capture anything after this point. So let's take a look at what it captured here for this particular callback. This is the one inside of start of simulation phase. So if you see down here, you can see the callbacks happening over here. You've got UVM phase ended, UVM phase cleanup, UVM phase done, and then the next one being scheduled. Okay, so that covers the callback. Let's go on to our next example, the new functions that have been added that are similar or complement the jump function. They're add jump phase and add prematurely. So these examples are going to be in our pre-reset phase over here. And in this example, I also create a callback here just so we have more information on the log file regarding what's happening here. And we actually grab the next phases over here, and we use the traversal to actually get the phase that's 2 ahead. So in this case, we're in pre-reset phase, so we're going to jump, 2 ahead, so that's going to be into the post-reset phase. So here are the two methods that we're interested in: send jump phase and end prematurely. So together they combine to have equivalent functionality to the already existing jump state. So now this gives you a little more fine-tuning, because you can set the jump phase, but then you can let the current phase end appropriately, which means going through the UVM phase ready to end and UVM phase cleanup. So in this case, this is a normal jump. So let's go ahead and look to see how it looks like. So we're basically down here. We've got the pre-reset happening, and then we go into UVM phase ended and UVM phase jumping. So that's how it looks like. So as an experiment, let's go ahead and comment one of these out. So let's say that we don't want to end the phase prematurely. We want the phase to end and go through these additional states. So let's go ahead and comment that out and rerun the example just to see what other phase states this example hits. Okay, so we're completed here. So let's get back to our jump point here. Okay, so as you can see, there's a couple more phases that we hit. We've got UVM phase ready to end, UVM phase ended, and UVM phase cleanup. And the jump still happens because you can see we go from pre-reset, then we skip the reset, and we go to post-reset. So similarly, you can do the example where we comment out the send jump phase and do end prematurely, and all we're going to basically see is the same thing as before, but the next phase is just going to be reset as opposed to post-reset. Okay, let's see where we are here. Okay, another thing to mention is we do have a new state, UVM phase uninitialize. So this is a minor change, which is basically the state is the first state, and whenever you create a phase and don't add it to the schedule, it's going to be in this state. So here we're actually down here we do an example here where we just create a new phase and then print out its state. So let's see, so this is in the build phase, so we should see this print out up here. Okay, here we go, build phase. So you see when we first created, it's UVM phase uninitialized. So you can kind of tell that this phase has not been scheduled. So this largely completes what I wanted to cover today. This last item is just something to mention, that in the sequences, the starting phase is now protected by get and set functions. So you can't access the starting phase directly. You have to go through these getters and setters.